Welcome back. This is Unit 1 for Physics, and this is the second video. We skipped over a couple of pages in the notes, page 3 and the top of page 4, because those require us to actually collect in-class data, which we have not done yet. We will do that as a class later. The first note, and this is something of a conclusion from the in-class lab, but it applies to some of the things that go on in this page. So I'm going to introduce it, and then in the video that describes our data for the in-class lab, we will be able to understand this a little better. But the first thing to note here is you cannot average averages, meaning that you can't take two average speeds and put them together and find a new average. A lot of times it's not going to work. The only way to find average speed for now is to divide the change in distance by the change in time. So we're going to work some examples involving average speed. So here we are, example A. An object travels at an average speed of 5 meters per second for a time of 8.5 seconds. Find the distance traveled. What I like to do first is just figure out what I have in front of me. Average speed, or otherwise known as average velocity. 5.0 meters per second. Time, 8.5 seconds. I'm just going to write T above it. And we are looking, it says find the distance. Something I've noticed over the past few years in physics, a lot of problems arise because students don't actually know what they're looking for. Find the distance. We're looking for D. So let's look at our formula. Remember, average velocity is distance over time. But we are actually looking for distance. So we're going to multiply both sides by t. Distance equals average velocity times time. Remember, this is one of the things that I need to see when I'm grading your work. I need to see the formula in symbols arranged how you're going to put in the numbers. So now we can put in the numbers. Average velocity or average speed, 5.0 meters per second. Make sure you leave the units in the calculation. Times the time, which we have as 8.5 seconds. So if you're paying attention to the units, the seconds will cancel, and that leaves us with an answer that is strictly in meters. So calculator answer, 42.5 meters. And if you look at the significant figures, we have two significant figures and two significant figures. So our answer should also have two significant figures. And so with significant figures, we would have 43 meters. Little summary sentence at the bottom, the distance is 43 meters. Example B, light travels at a speed of 186,000 miles per second. How long does it take sunlight to reach the Earth from the sun? So let's take a look at what we know. We know this is the speed. There's average velocity. And what is it we're looking for? How long? How long is a question relating to time. If you'll notice, we only know one numerical value out of 3, right? Because we have average velocity is distance over time. Looking at what we have average velocity, we are looking for time, and we need to know the distance between the Earth and the Sun. The distance between the Earth and the Sun is 93 million miles. Use the abbreviation. 93 million miles. And we're looking for time. Now, as we're looking for time, we need to solve for it first. I'm going to clean this up and change it a little bit. The simplest way to solve for time is if you look at the formula like this: velocity average over 1, which is the same as just velocity average, equals distance over time. So basically what we're going to do is we are going to swap the location for time with the location for velocity. And so the formula that we come up with, time equals distance over average velocity. So now we have our formula in symbols, and we have our numbers. Distance of 93 million miles. Average velocity of 186,000 miles per second. And what we find, let's cancel miles. Miles on top, miles on bottom. It takes 500 seconds. In terms of minutes and seconds, we're talking about 8 minutes, 20 seconds. You could say it takes 8 1/3 minutes. Make sure I'm at 1/3. It takes 8 1/3 minutes. 500 seconds would be an acceptable answer. No problem there. The question doesn't say how many minutes and seconds. It just says how long. But any one of these 3 things would be an appropriate answer. These next examples are a slightly different type of problem. They're a little bit more complex. Bill averaged 40 miles per hour for the trip to Chicago, a distance of 120 miles. He averaged 50 miles per hour for the return trip. Find his average speed for the round trip. So this type of problem does best when you use a chart. And you've probably seen this type of a chart in your math class before. Distance equals rate times time. Each one gets their own column. And we are going to have 3 rows. The trip to Chicago, the trip back from Chicago, and the total. So we're going to fill in the information that we know. Bill averaged 40 miles per hour. That's an average velocity for the trip to Chicago. So V average, that's going to be R, rate, 40 miles per hour. We know the distance is 120 miles. Keep moving along with what we know. He averaged 50 miles per hour for the return trip. So here's our 50 miles per hour for the trip back from Chicago, the return. And this is all of the information that we have from the question itself. Out of 9 pieces of information, we are only explicitly told 3 things. But there are some assumptions that we can make. If the distance to Chicago is 120 miles, we can reasonably assume the trip back from Chicago is 120 miles. So the total distance, if I drove 120 miles, turned around and drove another 120 miles, that's 120 plus 120. 240 miles. The question itself is asking for average speed for the round trip. And I'm going to box that in a different color. We are looking for the average speed or the rate for the round trip, the total. So we're looking for the orange box. Now, if you think back to the statement that is at the top of your page, you cannot average averages. So you need to resist the urge to add these two together and divide by 2. It's not 45. So we have to be pretty careful here. The way we're going to find this, we're going to do time equals, let's keep it consistent and use the same symbols. Time equals distance divided by rate. So distance of 120 miles at a rate of 40 miles per hour. And this is going to be 3 hours. So let's put this one in green since it's something that we calculated here. 3 hours. Can we figure out how long it takes us to get back from Chicago? It's going to be the same thing, same formula. Time equals distance divided by how fast were we going. 120 miles divided by 50 miles per hour. We're making it out of town a little bit faster. And we come up with 2.4 hours. $2.4. So think about this. I knew that I drove 120 miles to get there. I knew it was 120 back. And when I added the total distance that I drove, it was this number. In the same way, I drove for 3 hours and I turned around and drove for another 2.4 hours. That means I was on the road for a total of 5.4 hours. the last thing that I want to know, and this is what I'm actually looking for, is the rate. So I'm going to say R equals, make it orange so we know what's going on here. And this is going to be rate distance over time. Distance over time. That's how we find rate. Total distance for the round trip, 240 miles. Total time for the round trip, 5.4 hours. And so we put that into our calculator. We find, it is 44.4 miles per hour. And so this is the answer that we find, 44.4 miles per hour. Remember, we can't average averages. If we were to average the two speeds, the speed to Chicago and the speed back from Chicago, we would not have found this answer. In this particular example, they would have been close, but it would have been wrong. It's 44.4. Example D is fairly similar. For example D, I'm going to leave this one blank. You're going to give it a try on your own, and we can discuss it in class. But just remember that it's going to work fairly much, mostly the same as the one we just saw. Question E. Superman averaged 30 miles per hour for the 240-mile trip to Lois Lane's house. How fast will he need to fly back home so that his average speed for the round trip is 60 miles per hour? So let's start off with our table. And we can arrange our information, see what we know, see what we can figure out, and we'll move on from there. A lot of times what I find is in questions like this, rather than write down what we know so that we comprehend what's going on, a student tendency is to just stare at the question. Staring at the question is not going to get us very far, so it's best to start filling in the things that we know and then moving on from there. We'll see the relationships once it's in this table. So we'll say 2, back, and total. First, writing in the things that we know. Superman averaged 30 miles per hour for the 240-mile trip to Lois Lane's house. So average 30 miles per hour to. That's the R. That's the average velocity. The distance is 240 miles. The question says, how fast will he need to fly back home so that his average speed for the round trip is 60 miles per hour? That's this box here, 60 miles per hour for the round trip. Now, we have a lot of empty boxes, and it's going to be the same as the previous examples. We know how far it was to get there. We're going to assume it's the same distance to get home, 240 miles. 240 plus 240, round trip 480 miles. Just as a recap, how fast will he need to fly back Eventually, we are looking for the center box. How fast will he have to fly back? So let's work through the things that we can. We can figure out how long Superman was in the air on the way to Lois Lane's house. Time, that's distance over rate. How far did we go? How fast we're moving? That's going to tell us how long. 240 miles, 30 miles per hour. We're going to find that the flight required 8 hours of Superman's time. Hopefully you didn't put this in your calculator. You could really do it without. So let's cancel miles. If you were to drop the zeros, you have 24 divided by 3, and that's 8. So let's write that in here. We have 8 hours flight time. So we're going to have to figure this out. How long is this round trip going to take? We don't have enough information to figure out the time on the return trip yet. But if we figure out how far the total distance is and how fast he wants his average speed to be, we can figure it out. So time equals distance over rate. 480 over 60. This is another one that you could do in your head. So don't pull the calculators out just yet. If you were to cancel out some zeros here, you've got 48 over 6. 8 hours. So let's put our number in here. So now we have to figure out how long does Superman have to get back to his own house. It took him 8 hours to get there. But if he wants 60 miles per hour to be his average speed, he only has 8 hours for the round trip, which means that he is out of time. And if you were to look at the formula here, let's keep it here. Rate equals distance over time. We're talking about 240 over 0. It is impossible. He could fly at near the speed of light, still wouldn't make it back in time. He has no time left. All right, we're going to stop there. We'll pick up with the next video.